Introduction to Object Orientation. Presented by Kamor Masharia. Note that this is a compilation of different materials with the aim to reach out the visual impaired and wish to learn these concepts through audio. Areas to be covered. Introduction to Object-Oriented Concepts. Objects. Classes. Encapsulation. Inheritance. Polymorphism. Object-Oriented Analysis, OOA. It involves two processes. 1. Identifying software engineering requirements. 2. Developing software specifications. It has interacting objects. Note that this is with respect to software systems object model. The main difference between object-oriented analysis and other forms of analysis is that in object-oriented approach, requirements are organized around objects, which integrate both data and functions. They are modeled after real-world objects that the system interacts with. In traditional analysis methodologies, the two aspects, functions and data, are considered separately. The primary tasks in object-oriented analysis, OOA, are identifying objects, organizing the objects by creating object model diagram, defining the internals of the objects, or object attributes, defining the behavior of the objects, i.e., object actions, describing how the objects interact. Object-oriented design, OOD. It involves implementation of the conceptual model produced during object-oriented analysis. Concepts in the analysis model are mapped onto implementing classes, constraints are identified and interfaces are designed, resulting in a model for the solution domain. The implementation details generally include restructuring the class data, if necessary, implementation of methods, i.e., internal data structures and algorithms, implementation of control, and implementation of associations. Object-oriented programming. Object-oriented programming, OOP, is a programming paradigm based upon objects, having both data and methods, that aims to incorporate the advantages of modularity and reusability. Objects, which are usually instances of classes, are used to interact with one another to design applications and computer programs. The important features of object-oriented programming are bottom-up approach in program design. Programs organized around objects, grouped in classes. Focus on data with methods to operate upon objects' data. Interaction between objects through functions. Reusability of design through creation of new classes by adding features to existing classes. Object. An object is a real-world element in an object-oriented environment that may have a physical or a conceptual existence. Each object has identity that distinguishes it from other objects in the system. State that determines the characteristic properties of an object as well as the values of the properties that the object holds. Behavior that represents externally visible activities performed by an object in terms of changes in its state. Objects can be modeled according to the needs of the application. An object may have a physical existence, like a customer, a car, etc., or an intangible conceptual existence, like a project, a process. Class. A class represents a collection of objects having same characteristic properties that exhibit common behavior. Creation of an object as a member of a class is called instantiation. Thus, object is an instance of a class. The constituents of a class are a set of attributes for the objects that are to be instantiated from the class. Generally, different objects of a class have some difference in the values of the attributes. Attributes are often referred as class data. a set of operations that portray the behavior of the objects of the class. Operations are also referred as functions or methods. Encapsulation and data hiding. Encapsulation. Encapsulation is the process of binding both attributes and methods together within a class. Through encapsulation, the internal details of a class can be hidden from outside. It permits the elements of the class to be accessed from outside only through the interface provided by the class. Data hiding. Typically, a class is designed
such that its data, attributes, can be accessed only by its class methods and insulated from direct outside access. This process of insulating an object's data is called data hiding or information hiding. Inheritance. Inheritance is the mechanism that permits new classes to be created out of existing classes by extending and refining its capabilities. The existing classes are called the base classes / parent classes / superclasses, and the new classes are called the derived classes / child classes / subclasses. The subclass can inherit or derive the attributes and methods of the superclass, ES, provided that the superclass allows so. Besides, the subclass may add its own attributes and methods and may modify any of the superclass methods. Inheritance defines an is, a relationship. Polymorphism. Polymorphism is originally a Greek word that means the ability to take multiple forms. In object-oriented paradigm, polymorphism implies using operations in different ways, depending upon the instance they are operating upon. Polymorphism allows objects with different internal structures to have a common external interface. Polymorphism is particularly effective while implementing inheritance. Benefits of object model. The benefits of using the object model are: it helps in faster development of software. It is easy to maintain. Suppose a module develops an error, then a programmer can fix that particular module, while the other parts of the software are still up and running. It supports relatively hassle-free upgrades. It enables reuse of objects, designs, and functions. It reduces development risks, particularly in integration of complex systems. Kindly, remember, to promote this click subscribe button, like and share your comment. Thank you.